All right, for 8.7, we're looking at systems of inequalities. So for our example here, we're going to start with linear inequalities, and then we're going to go to nonlinear inequalities. So this part should be a review again. So inequalities are a little bit different from systems of equations because the solution is actually going to be a graph. You're going to have a range of values. We're looking for all the y's that are greater than 4x plus 2. So this is where we're going to be shading regions of the graph that are all solutions to these inequalities. So the first thing that we need to do is to draw the boundaries. Now for lines, this is a little bit simpler because lines are easy to draw. So we're just going to go ahead and jump in and draw these lines. When we get to the nonlinear ones, it's going to be a little bit different. But the boundaries are the equations where these are equal. So y equals 4x minus 2, and y is equal to negative x plus 3. And you should recognize these as linear equations. We've got x and y with no exponents. So these should be fairly easy to draw. We know that we have the intercept and the slope. So starting with the first one, I'm sorry, I forgot to one important thing. These are our boundary lines. We've got to pay attention to the inequalities to decide if they're going to be solid or dashed. So if it's not included, it's going to be dashed. So I'm going to draw that first line as a dashed line. And if it is included, then it's going to be solid. So that's important to note before you start drawing anything, because you don't want to draw a solid line and then realize it was supposed to be dashed. So we're going to draw this line. Okay, we're going to find those points and we're going to put it in as a dashed line. So we're going to start at the y-intercept negative 2. And the slope tells us to go up 4 over 1. So up 4 over 1. You can do that again if you want to. Up 4 over 1. Or remember, you can also go down 4 back 1 if you want. So you should be able to draw that line and be pretty confident on it. And again, that's going to be a dashed line. Okay, so my tablet's not too happy with dashed, but that's the idea there. Okay, so we've got that line in as a dashed line. This other one is going to go in as a solid line because it's included. So we're going to start at positive 3, and our slope is negative 1, so we're going to go down 1, right 1, down 1, right 1, down 1, right 1. You can do that as many times as you want till you can see that line. And that one is going in, oh, sorry, off a little bit there. That one is going in as a solid line. Okay. All right, so we've got our two boundaries. And for linear ones, we're gonna, like I said, we're gonna have an extra step for the nonlinear. So for our linear ones, we get those pictures up there pretty good. And our second step is just going to be to figure out the shading. Now, in other classes, you may have done this a little bit differently from how we're going to do it. They may have told you to shade above, and then shade really, really hard where it overlaps. And we're not going to do that. We're going to shade only the solution. Okay, so the only shading that should be on this paper is just the solution. So how do we do that? Well, we use that idea of overlapping areas to try to narrow down which region it is, and then we're going to use a test point to know for sure. Okay, so we've got 4 different regions here. We've got this one right here, we've got this one right here. So here, I'll number them so you can see them. So there's region 1, region 2, region 3, region 4. Okay, just so you can see the 4 different regions. Our final shading is going to be one of these regions. All right. So let me take those back off again. Okay, so what we can do is we can use these inequalities to narrow down what we think the region is going to be, and then we can test a point to be sure that we got the right region. So if you've got a positive y and it's greater than, we've seen this before, if you've got y or f of x greater than, that means above. So we want to be above the first line. We want to be above the dashed line. And the second one is also y greater than, so we want to be above that one as well. So we want to be above the solid and above the dashed. So above the solid is this way. Above the dashed is this way. So the region where they overlap should be right here. That's our educated guess. So let's test a point and be sure that we got the right region. So pick any point that's in this region. We do not want it to be close to the boundary line. So let's maybe pick this point right here, because that's definitely not close to our boundaries. 1, 2, 3, 4, 5, 6. This is the point 0, 6. So I think 0, 6 is a solution. So I'm going to test 0, 6 in both inequalities and see if it's true. So in the first inequality, I've got 6 greater than 4 times 0 minus 2. Is that true? Is 6 greater than 0 minus 2? 6 greater than negative 2? Yes, that's true. Test it in the second equation. 6 greater than or equal to negative 0 plus 3. Is 6 greater than or equal to 3? Yes, that's also true. That means we picked the right region, and we can go ahead and shade that whole thing in. If one of these inequalities had not worked, that means that we picked the wrong region, and we would just have to go to another region and try a different point. And you just go through and test a point from each region until you get the right one. But if you can kind of make an educated guess, then that narrows down the amount that you have to test. Okay, so that's our first one.